Number 70. I'm glad you asked. A piece of molding is 13 by 7. I'm sorry, 13x minus 7 inches long. If a piece that is 2x plus 2 is removed, express the length of the remaining molding as a polynomial. So here's my piece of molding. The total length is said to be 13x minus 7. But we are going to cut it, and the part that is cut off is 2x plus 2. The little piece that's cut off is said to be 2x plus 2. And they want to know, how can you write this as a polynomial? Well, what if, let's think of a simpler example. What if I said it was 10 and this is 2? If this whole thing is 10 and this little part is 2, then how much is this? It has to be 8, right? If the whole thing is 10 and this is 2, 8's left. How did you know it was 8? Because 2 plus 8 adds 10, right? This goes back to, that's been ingrained for a long time. So if I said the whole thing was 10 and this was 2, you really quickly went, oh yeah, 2 plus 8 equals 10. Or another way to think of that is 10 minus 2 equals 8. Right? The whole piece minus this little part will give me this polynomial. So we're going to subtract the whole minus the part. The whole part is 13x minus 7. Subtract the part 2x plus 2. Boy, the parentheses are important because I'm not just subtracting the 2x, I'm subtracting the whole part. So this is going to make this be a negative 2 and a negative 2x. Both of those become negative. Now let's combine like terms. 13x and a negative 2x. Together, these two things add to 13 minus 2 is 11x. And then negative 7 and negative 2, those two add together as a negative 9. So we can express it as 11x minus 9 inches. This is inches here. Inches, inches. And here's your final answer. And again, I think it's a good policy if it helps you to circle these, and then once you've added them together, just cross them off so you can forget about them. And then circle these. Those are my two constants, and then draw lines through them to get rid of them. So you don't have to think about it again. Next question. Okay, 3-5. Multiplying polynomials. Questions from the homework. These are questions on page 232. Which ones would you like to see multiplying polynomials? Well, let's just do number 50. So we have something to look back at, just in case you want it. 3 plus b times 2 minus 5b minus 3b squared. Now sometimes b's look like 6's. If you ever want to just change those letters to an x in your homework, that's fine. You can always change it, doesn't matter. I have 2 terms times 3 terms. So we're going to do repeated distribution. We're going to take 3 times 2, then 3 times the middle term, then 3 times the last term. Once we've gotten those 3 products, then we're going to start over. Take b times the first, b times the second, and then b times the third. Altogether, we'll have 6 products that we add into one final answer. 3 times 2, I'll write it all out here so you can see this. 3 times 2 plus 3 times negative 5b plus 3 times negative 3b squared. That's the 3 red ones, so I'll underline those. Plus, now let's do the blue ones. B times 2 plus b times negative 5b, and then b times the last. I think it's easier for me to separate these, each product with addition to start with, and then if I've got a negative, I have it inside my parentheses, and I'll work that out as I multiply each pairing. So some of these additions will maybe change the subtraction when I finish multiplying. 3 times 2 is 6. 3 times negative 5 is a negative 15 times b. 3 times negative 3 is negative 9, b squared. And now the blue ones. B times 2 is 2b. Negative 5b times b gives me negative 5b times b is b squared. And finally, plus a negative 3b cubed. I'm kind of in opposite order, right? Usually we have our highest powers first. Do you see anything I can add together?
B squares.
What?
The B squares.
The b squared, this guy and this guy. I don't know if you noticed, but I'm still writing this as plus a negative, plus a negative. I just think it's easier to keep track of what I've got. I'm going to add these two things together. I think while we're at it here, I will also add 15 and 2. Negative 15 and positive 2. So 6 doesn't have anything to add to it. 15 and 2 add to negative 13b. Because this is a negative 15 and a positive 2, I actually find the difference and attach the sign at the one that's more negative, which is a 15, plus negative 9 and negative 5 is a negative 14b squared, plus a negative 3b cubed. I'm going to quit there. Probably the back of the book started with negative 3b cubed. They would put it in that order, but they would probably put it in from highest power to lowest power. Yes, that's what they did. Anything else from 3.5 before we go on?
Number 10.
Number 10. Thank you. Number 10 is a product of a fraction, negative 3/4 y to the 7th power times 1/7 y to the 4th. In this problem, we have to think about, number one, how do I multiply fractions? But then also, what happens when I multiply things that have the same base? Y to the 7th times y to the 4th. You don't have to write it out this way, but what happens mentally is I usually put the numbers together in my mind. Negative 3/4 times the 7. Multiplication is commutative, so I can put the two numbers together. Then I multiply that times the two y's together. Y to the 7th, y to the 4th. Multiplying fractions. When you multiply fractions, you remember the song, multiplying fractions, that's no problem. Top times top and bottom times bottom. So I don't have to have common denominators because I'm not adding. Right? I'm multiplying. When I multiply them, I just take top times top and bottom times bottom. That gives me a negative 3 over a 28. 3 does not go into 28, so I cannot reduce that. And now I have y to the 7th times y to the 4th. When I multiply two of these y's when they have the same base, then I'm actually going to add the powers. Multiplying here means adding the powers. Remember we said that y to the 7th really equals y times itself 7 times, right? Y to the 7th power is y times y times y times y. So I'm just going to write that out. 4, 5, 6, 7. That's 7 y's. And then y to the 4th is y times itself 4 times. Right? How many y's do I have altogether?
11.
7 of them here, 4 of them here, right? That's how I remember that when the bases are the same, I add the powers. So sometimes I question myself, like, should I multiply the powers? Because I'm multiplying. Then I'll write one of these out. I don't usually choose to the 7th power because a lot of y's, but if you take y cubed times y to the 4th, and just kind of work it out this way, you'll go, oh yeah, I have to add those. That's how that kind of works out. And the common sense of it will help you remember the rule for that. Okay. Section 3.6 talked about special products, where we were multiplying, but we said that there's some special cases where a lot of things cancel, and I don't have quite so many terms in some special cases.